Alright guys, here is our video on the practice problems. So we're doing the practice problems just like this worksheet right here. I'm going to do it on paper for you. Alright, so number 1, given the derivative, determine the critical points. And if they are relative max, relative mins, or neither. Alright, so number 1. We have f prime of x is equal to x squared times x cubed minus 5. So to find our critical points, we set that equal to 0. And we're going to set each piece equal to 0. So we get x is equal to 0. And here, we get that x is equal to the cube root of 5. Okay? Now, again, we didn't take the derivative because they gave us the derivative. So you do need to make sure that you're looking at what it is they gave you. Now, these two things are critical and stationary points. So when we go into our table, we're going to put in 0 and the cube root of 5. And we need to find out if these are relative maxes or relative mins. So we need to plug them into our derivative. So you're taking the values right and to the left of both of these numbers, and we're plugging them into our function. Now remember, when you're plugging them into that derivative here, x squared, always going to be positive. So really you're just looking at this. Now x cubed, you plug in a negative, you're going to get out a negative. You plug in a positive, you're going to get out a positive. So just keep that in mind. What you need to determine is that number bigger or smaller than a 5. So if we put in a negative 1, you're going to get out a negative. And a negative minus a negative, or minus a 5, that's going to continue to stay negative. Now, the cube root of 1 is 1. So the cube root of 5 is going to be bigger than 1. So I'm going to plug in a 1 right here. Okay? Because the cube root of 1 is 1. So I'm pretty safe to say that if I plug in a 1, that's going to be less than the cube root of 5. So if I plug in a 1, I have a 1 cubed, which is just 1 minus 5. That's also going to be negative. Now, the cube root of 8 is 2. So I know that the cube root of 8, which is 2, is going to be bigger than the cube root of 5. So I could plug in a 2. Now here you have it a little bit easier. Because you can plug in a 10 or 100. You can plug in anything as big as you want. Because that's it. That's as far as you're going. Anything to the right. So anything bigger. So if you get nervous, is 2 bigger than the cube root of 5? You can always pick something even higher. But if you plug in a 2, 2 cubed is 8. Well, 8 is bigger than 5, so that makes this a positive. So this decreases and then decreases, which means you don't have anything as far as a relative max or a min. This would be a neither. This decreases and then increases, so decreases and then increases means that you have a relative min. So you have a relative min at x equals 0 because f prime of x changes from negative to positive. Okay, so that's number 1. Now, if you need to copy it down or something, go ahead and push pause, and you can copy it. Number 2. Number 2, they gave you f prime is equal to x to the 4th times e to the x minus 3. So again, we need to set this equal to 0. So x to the 4th equals 0. E to the x minus 3 equals 0. So here x is just going to equal 0. Here, you've got e to the x is equal to a positive 3. Well, we need to solve for that x. Well, anytime you have an x and an exponent, you can't solve for it up there. Well, the neat thing that allows you to bring it down to the front is an ln. Well, you can't just take the ln of one side. You got to take the ln of both sides. And what's neat about that is it gets this exponent out of the exponent and it pulls it down in the front. So you end up with x ln of e equals ln of 3. Now what's also nice is we know ln of 3 is ln of e is just equal to 1. So it then allows us to see that our critical point is the ln of 3. Okay? So these are our critical stationary points that we can put in our table. So we've got a 0, we have an ln of 3, and we're looking at our derivative. So here is our derivative that we're plugging it into. Now again, look at x to the 4th. X to the 4th is an even number. Even means that it's always going to be positive no matter what you plug it into. Now, e to the x. Is e to the x, where is it positive? Where is it negative? Well, let's look at e to the x. If we remember the graph of e to the x, that's going to help us figure things out. E to the x is positive no matter what. So we just need to figure out if it's bigger than 3 or if it's less than 3 when we're plugging things in. But think about e to the x is just the number of 2.7. Okay, it's just the 2.7. Keep that in mind. So if we plug in, say, a negative 1. So if we plug in a negative 1, you've got e to the negative 1 minus e. That's 1 over 2.7 minus 3. Because e to the negative 1 is 1 over e. E is just 2.7. So this is some fraction minus 3. That's going to be a negative value. Okay? Now, something bigger or smaller than ln of 3. Ln of 3. Well, maybe if we looked at the graph of ln, that might help us out a little bit. There's the graph of ln x. Ln of 1 is equal to 0. Okay, ln of 1 is equal to 0. And then you've got, here's 2, and there's 3. So if I plug in a 1 right here, I think I'm going to be okay. Okay, I'm going to be okay. Because ln of 1 is just equal to 0. So I think I'll be okay with just plugging in a 1. Well, let's look here. If we plug in a 1, e to the 1 minus 3, that's 2.7 minus 3. Still negative. Now, I need to plug in something to the right of ln 3. Now, I don't really know exactly what ln 3 is. I believe you do if you're in physics. Physics isn't my favorite subject, but here's the deal. I'm going to plug in something like a 5. Because again, I don't care. There's nothing else to the right of it. So if I have 2.7 to the 5th minus 3, okay, well, I know 2.7 squared is going to be bigger than 3. So since I know that that's going to be bigger, I've got a positive value right there. So this is neither. This one, decreasing, increasing, you have another relative min. So you have a relative min at x equals ln 3. Remember, that's just some decimal, some number, because f prime of x changes from negative to positive. Again, you can hit pause if you need to copy some more things down. Let's look at number 3. Number 3, to give us that f of x, or f prime of x, is equal to the ln of 2 over 1 plus x squared, which we want to set equal to 0. Solving this thing for 0. Well, I really can't do anything right here, but I can change this to be log base e. And now I can do my log loop. So if I do my log loop, I get that e to the 0 equals all this stuff. E to the 0 equals all of this. Well, e to the 0 is just 1. Anything raised to the 0 is just 1. So I get x1 plus x squared equals 2. or x squared equals 1, or x equals plus or minus 1. So those are my critical points. Okay. Now, I've got to plug this into the derivative. But my derivative is this ln. Well, here's the nice thing about the ln derivative. You're going to use this graph right here to help you figure it out. Okay? Anything that's in between 0 and a 1 is going to have a negative value. Anything that's bigger than 1 is going to have a positive value. So you're using your graph to try and figure it out. Because remember, we don't need the exact numbers. We just need to know, are we taking the ln of a fraction, or are we taking the ln of a number bigger than 1? So if I plug in a negative 2. All right, well, negative 2 squared is 4. 4 plus 1 is 5, so it's the ln of 2/5. Well, 2/5 is less than 1, so that's a negative value. So now I'm going to plug in something that's, in between negative 1 and 1, which 0 makes sense. So if I plug in a 0, that's 0, so I end up with 2 over 1. Well, the ln of 2 over 1, well, the ln of 2 is some positive value. So we don't need to know the actual number in order to know whether it's positive or negative. And then I'm going to plug in a positive 2, positive 3. But again, that's the same as the negative because I square it. So that's the ln of 2/5. So I'm back down to negative again. Now I've kind of run out of space, but you're going to have a relative min at negative 1, and you're going to have a relative max at positive 1. Don't forget that plus or minus. There's one on the test where you've got to have the plus or minus, and forgetting that other thing, you're missing one of your entire relative maxes or mins. So just to finish up with number 3, you're going to have a relative min at x equals 1, negative 1, because the derivative is going to change from negative to positive. And then you're going to have a relative max at x equals positive 1 because f of x changes, or f prime of x changes from positive to negative. Okay, again, here's number 3's work. I'll get it in there in a second. You can go ahead and pause now if you want to take a look at it. All right, let's go on to number 4. So number 4 says, if x equals 3 is a relative extreme, which means we know that it's either a max or a min, and they want you to find k. Now, k is just going to be some constant, so it's going to be some number. So let's look at a. F of x is equal to x squared plus k over x. Okay, x squared plus k over x. So I want to find the derivative first. I get 2x. Now this is just going to be equal to k times x to the negative 1. So if I'm doing the derivative of that, that's going to be negative k x to the negative 2. Okay? So we need to set that equal to 0. Now here's the deal. They said that x equals 3 is a relative extreme. That means that when x equals 3, your derivative should equal 0. So we have 2 times x minus k over x squared equals 0, when x should equal 3. So 2 times 3 minus k over 3 squared equals 0. So we get 6 minus k over 9 equals 0, and now we can just solve. So I subtract the 6. Then I'll go ahead and I'll multiply by a negative 9. And I end up with k is equal to a positive 54. So that is part A. Part B. Part B, they told you that f of x was equal to, let's find it, x over x squared plus k. Okay, x over x squared plus k. So, derivative. We need the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And we need to set that equal to 0. Now again, here's our deal. We know that x is equal to 3. Oops, so here. Because you have a relative max or a min at 3. So that means when the derivative equals 0, x has got to equal 3. So 9 plus k minus, that's 2x squared, so that's 2 times 9, all over 9 plus k quantity squared equals 0. Now, do we care about this denominator at all? Nope, because it's going to go ahead and equal 0 when you multiply it. So we have 9 plus k minus 18 equals 0, or k minus 9 equals 0. So k equals 9. Again, pause and take a look. Let's go ahead and look at number 5. Number 5, they want you to find the critical points and use the second derivative test if they are relative max and mins. Find the critical points and use the second derivative test. That should say to find out if it is a relative max or a min. For f of x is equal to sine 2x if your x is between 0 and pi. All right, so our first derivative, the derivative of sine 2x is cosine 2x times 2. Don't forget your chain. And you need to set this equal to 0. Well, you're going to divide by 2, which means you're just going to have cosine of 2x is equal to 0. Now what you need to do is you need to figure out where cosine is equal to 0. Okay? Cosine, if you've got your graph right here, cosine is going to equal 0 at pi over 2 and 3 pi over 2. Okay? So to find x, you have to say 2x is equal to pi over 2 and 2x is equal to 3 pi over 2. Now, I know 3 pi over 2 is bigger than x. It's bigger than pi. But it's the x that needed to be between 0 and pi, not the theta, not where cosine was. Because when I divide by 2, I get pi over 4 and 3 pi over 4. And both of those x's are within this domain of 0 to pi. Okay? So I know in my table that I've got pi over 4 and I have 3 pi over 4. Now, they wanted us to do the second derivative test. So I'm really only worried about the second derivative test right now. So I find the second derivative. Well, the 2 comes down. The derivative of cosine 2 theta is a negative sine, it's 2x, not theta, times another 2. So my second derivative is negative times 2 is negative 4 sine 2x. Now, I don't need to set this equal to 0. I'm not asking for my pips. What I'm asking to do is I want to plug in these values into my second derivative to see whether they're positive or whether they're negative. Because if they're positive, then I have something that's concave up and I have a relative min. If they're negative, I have something that's concave down and I have a relative max. So if I plug in pi over 4, what you have to do is you have to simplify this before you determine what it is. So 2 over 4, this is negative 4, the sine of pi over 2. Okay? The sine of pi over 2 up here is just 1. So this is negative 4 times 1, so that's a negative value, which means you have a relative max. So let's do the same thing with 3 pi over 4. So that is going to reduce, and we have negative 4, the sine of 3 pi over 2. Well, down at the bottom of the circle, sine is a negative 1. So that means that's equal to a positive 4, which is concave up, which means you have a relative min. So to finish that off, x equals pi over 4 is a relative min. Why? Because the second derivative is, is less than 0. It's negative. And x equals 3 pi over 4 is a relative max. Oh, I'm sorry. This one is our max. Let's get this right. I'm looking at it and I'm like writing the wrong thing. All right, so x equals pi over 4 is our relative max because our second derivative is negative. X equals 3 pi over 4 is our relative min because our second derivative is positive, greater than 0. Okay? All right, so this is already 20 minutes, so I'm going to pause this. And what I'll do is I'll do the second half a little bit later.